Hello and welcome to this further maths video on finding the perpendicular distance between points and lines and between two lines. So we're starting with the diagram at the top of this page, which shows a line going through AB and a point P, and we're being asked to find the shortest distance between the point and the line. Quite often asked to do this in exam questions in a context of perhaps a ship or an animal running past a point or sailing past a point. When is it closest to some other point here? When does it pass at its closest point? So there's a general method to this. The general method is to draw a diagram, find the point or call the point X that you're trying to find. This point here is the shortest, the point at which it's the shortest distance from P. Work out the vector Px and use the fact that that's perpendicular to the line. So let's see how that works in a particular example. So what we've got here is a line given in Cartesian form, but we're going to want it in vector form in order to do this question. So remember that to change from one to the other, it's good to think of that as being over 1. The numbers on the top give you the point on the line. So this is the line r equals 2 minus 2, 1. That's the point on the line, plus lambda times the direction vector, which is on the bottom, which is 1, 3, 2. So that's our line. And we've got this point 2 minus 1, 3. So if we draw a rough sketch, and this does really help, here's the origin somewhere over here. This is my point P, and I'm trying to find that point there, X, because if I find X, I can find the distance Px quite easily. So the first thing to do is find the general point on the line. How do I get from O to X? Well, if it's on the line, then it's going to look like this. It's going to be a point on this line. So that's going to be 2 plus lambda minus 2 plus 3 lambda, 1 plus 2 lambda. So that's a point on the line. I now need to find what's the vector from P to X. So the vector from P to X is going to be P to O plus O to X, or you could think of that as being O to X minus O to P. Doesn't really matter how you think of it, but you need to get to that point. So we need to do, say that P to X is going to be our vector here, OX, minus the vector to get to P, which will be 2 minus 1, 3. So we're going to have 2 plus lambda minus 2, minus 2 plus 3 lambda plus 1, 1 plus 2 lambda minus 3, and then tidy that up, lambda minus 1 plus 3 lambda minus 2 plus 2 lambda, and that needs a bracket. So what we've done there is we've found the vector that takes us from P to X by using the general point, the vector for P, and the general point on the line. Now, what do we know about Px? We know that Px dot product, find the dot product of that with the direction vector of this line, 1, 3, 2, will be equal to 0 because they are perpendicular. So I'm going to do the dot product of this vector here with 1, 3, 2. So 1, 3, 2, dot product of that with lambda minus 1 plus 3 lambda minus 2 plus 2 lambda equals 0. So working this out, I'm going to get lambda minus 3 plus 9 lambda minus 4 plus 4 lambda equals 0. This gives me 14 lambda equals 7, or lambda equals a half. Now that I know the value of lambda, I can actually work out here what the point X is equal to. So I can work out what the point x is equal to, but actually what we're asked is the perpendicular distance. So we actually want the length of px. So I need to put lambda back into here. So if lambda equals a half, p to x is going to be a half. Putting in a half here, that's going to give me another half. And putting in a half here is going to give me -1. So that's that vector there, p to x. But I want to know the perpendicular distance. That's going to be mod px, which is a half squared plus a half squared plus -1 squared, all square rooted, which gives square root of 3 over 2. But the general method is the same for these questions. Find a general point on the line. Yep. Find the vector that takes you from p to x, the closest point you're trying to get to. What do you know about that vector? You know that it's perpendicular to the direction vector of the line. So you can use the dot product. You'll get a value for lambda, substitute it back in, then use Pythagoras to find px. Right, moving on, we also need to be able to find the shortest distance between two lines in 3 dimensions. This can be quite difficult to picture. If you've got 2 pens like that and you put them so that they're skewed, you might be able to see that this distance here is the shortest distance between the 2 lines. So let's see how we go about finding that. Try to draw a diagram because it does help you. So we've got, here's my line 1. So this is, I'm going to call this line 1. And here's line 2 down here. And what I need to do is find a general point on line 1, a general point on line 2, and then use the fact that this vector AB is perpendicular to line 1. So when we do the dot product with 0, 1, 1, it will be equal to 0. It's also perpendicular to line 2. So when we do the dot product with 2 minus 1 minus 1, it will be equal to 0. And then we solve it and find the value of lambda or mu. So let's see how that works in this question. General point on a general equation for O to A is going to be, just combining this here, 1 lambda lambda. General point on B is going to be -1 plus 2 mu, 3 minus mu, minus 1 minus mu. So those are my 2 general points. I want to find the vector AB. So AB is going to be the vector OB minus OA. So that's going to be OB -1 plus 2 mu, 3 minus mu, minus 1 minus mu, minus 1 lambda lambda. And so when I work that out, that gives me -2 plus 2 mu. It gives me 3 minus mu minus lambda. So we are going to have mu and lambda in this general point vector here. -1 minus mu minus lambda. So that's my vector that takes me from A to B. Now I know that AB dot 0, 1, 1 equals 0 because this vector is perpendicular to the direction vector of L1. I also know that AB is perpendicular to line 2, which is 2 minus 1 minus 1. So that is also equal to 0. So I'm going to do the dot product of this vector here with 0, 1, 1. That's quite a nice, easy one to do. So that gives me 0 multiplied by -2 plus 2 mu. It's also going to give me 3 minus mu minus lambda, -1 minus mu minus lambda equals 0. So let's see what we get here. This is going to give me 2 equals, I'm going to put the lambdas and the mu's on the other side of the equation, 2 mu plus 2 lambda. So 1 is equal to mu plus lambda. This one here, it's not going to be quite so nice. We've got to multiply it by 2, then by minus 1 by minus 1. So I get minus 4 plus 4 mu minus 3. And be very careful if you're multiplying by a minus, plus mu plus lambda. And then again, plus 1 plus mu plus lambda equals 0. And then when I tidy all of this up, I'm going to get, how many mu's have I got? 6 mu plus 2 lambda is equal to, that's minus 7, minus 6 is 6 if I move it over to that side. So that's 3 mu plus 2 lambda, sorry, 3 mu plus lambda equals 3. So you can imagine what's going to happen now. We've got 2 simultaneous equations and we're going to subtract them. So we're going to do equation 2 minus equation 1. So if I do equation 2, take away equation 1, then I get 2 mu equals 2, so mu equals 1. And that tells me that lambda equals 0, just substituting it back into here. Now, what does the question ask for? The shortest distance. So we need to find out what AB is. We're going to use lambda equals 0. That's a nice easy one. So AB, the vector AB is equal to, so we're going to substitute back into here. So we're going to get 0 for the top line. If I substitute 1 and now I'm going to get 2 there, minus 1, minus another 1, minus 0, so that's minus 2. So that's my vector. The modulus of AB, because it asks for the shortest distance, is going to be 0 squared plus 2 squared plus minus 2 squared, square rooted, which is the square root of 8. And that's how you find the shortest distance between 2 skew lines.